Well, welcome back. It has been a very long time since I've uploaded a video, and there's been so much feedback from you guys regarding where am I? Well, you're probably asking where have I been for the last 6 months? It's not because I've had been busy with the family, nor has it got anything to do with me winning the lottery, or is it to do with me dying from a fidget spinner. But sadly, the truth is I have been busy with work. And now that work has got to a point where I'm a bit more free and flexible, I'm hoping to get back onto YouTube, upload some video projects I've been working on in that period of time. And the work itself is very involving, but I like to always make the effort with the video content and upload it, mainly because I think it makes it more for an interesting viewing experience than the subject that we're dealing with. Okay, so without further ado, let's just show you what I've been up to.
Coming real, it's the next episode.
So let's discuss some of the updates I've had regarding the projects I've been doing and past projects that have been completed. The first thing I want to update you guys is regarding the iris enclosure for a 3D printer I produced last year. Initially, that was just for me to share my thought processes of designs and my version of how an enclosure should be for that particular printer. But I never knew that the response would be so big regarding other people wanting to replicate that design. I must apologize to a few people that have been patiently waiting and nothing's been available from my side. Mainly this is because the design isn't so final. There is some minor tweaks I need to do to the design, and so what I'll do is I will produce a concluding episode of that enclosure, and once I do that, that design will be available on Thingiverse. If anybody wants to replicate that design for themselves, just send me a message, send me a picture of what you've done, and just make sure that I get acknowledged for that design because I put the work in. As well as the iris enclosure, I'm also looking to produce an enclosure for the original Prusa i3 Mark II. I've got a couple of ideas that I'm toying with and putting a concept to my CAD screen. I think once I've developed a concept that may work and is easily replicated by people, then I think I will do an episode on that one because I just want to see what you guys think. Regarding the 18650 recovery, those are all completed. I have recovered all of the 18650 I own. There's been bags and bags of rubbish that I've had to throw away, some raised eyebrows at the recycling centre. I'm still looking for my next big haul of 18650 laptop cells for further recovery, but that's not such a high priority at this stage. The next phase is really to process over 6,000 cells I do have and put them into their corresponding groups so that I can use it for whatever I need to use it for. Right, on to Project JU, the most anticipated machine that needs to be built for this community that is growing rapidly. Things are progressing slowly. There's no two ways about it. It's been a steep learning curve for myself. This has always been an exercise for me to learn new skill sets. I've always wanted to learn electronics, programming, even circuit design and PCB design, and this is ticking all those boxes, but it's the time that it takes to learn this stuff and commit to doing I don't have, but when I do have time, I do put the work in. So right now I'm researching several types of relays. Relays are paramount to the way that this machine works in processing cells automatically, but also the size of the relays will also govern the shape of the machine and how big it's going to be. I want to send out a massive respect to Pete at HP Powerwall. That forum is really come leaps and bounds. I especially like the new incentive that the forum has taken regarding a community cell counter, or a cellathon as I like to call it. I think that will both encourage people to increase their battery sizes and create a little bit of friendly competition, although some of those numbers on that forum are a bit dubious and I think they need to be checked carefully. It'd be nice to have that meter or the cell count at the front of the forum where it's easily found, and I think it'd be a really nice thing for people to quickly check when they log in. For this one reason, I really need to pull out all my fingers and thumb and get on with processing my cells. So how can I accelerate and catch up with everybody else with the 6,000 cells? This is a nut. The sole purpose of the nut for humankind is to get to the center where there's all the goodness. And there's two ways to do this. You can use the right tool, which is in this case a nutcracker, or if you don't have the right tool, a nutcracker, you improvise. And improvisation comes in many forms. You can improvise this way with a bigger hammer, or you can improvise this way with an even bigger hammer. Now, how can I put this into the context of the cell processing? Do you remember a year ago I created the awesomest battery charging thingy unit, which is going around the world right now? I don't know who's got it. If anybody knows where it is, just send me a message so we know where it is and pass it on to the next person. But that was a 22 bank or a 20 bank charging system. And there's been a fair few people online that have been making some more charging units, and they've been really good. So what I propose is that we are going to make the world's biggest charger, which I will call the Big Friendly Charger, BFC. Yeah. So let's just get on with it. You're here for one reason, is to see a design of something spectacular. We're going to design the world's biggest charging unit for 18650 cells by using 66 cells at once to charge. I would be as bold as to say that this is going to be the world's biggest single battery charging unit in the world. The first thing I like to do is I want to bring in the basic components, which is going to be a battery holder and the TP4056 that we're going to use for this BFC. So just to see how much space would take, we can create an array that goes 33 across and 2 down. Right, and there we have it, 66 holders with 66 TP4056s. By doing this, I can then figure out how big is the board going to be. So if I just do a quick measure of that, and give or take an inch either side, but talking close to 1 meter in length. And if I measure the top height and bottom height, 234. So give another inch either side as a frame. We're talking a board which is about a meter in width and about 270 millimeters in height. I do not know what that is in inches, so just pull out your calculator, work out yourselves. That is far too big for me regarding worktop real estate, which is in precious demand. So I'm thinking, why don't we try something different? And why not try it in a circular pattern and see what happens there? Now we try the array. So again, circular array, select our central axis. We want to make it 66 units. 360 divided by 66 gives us the angle for each unit. Yeah, I think that doesn't need to be so far spaced apart, so we can bring them closer together, almost touching in my opinion. All we need to do is amend this dimension to 300, maybe even closer to 60, and maybe even more closer to 50. Oh, that's too much. Oh, I did 150 there. There we go. Let's see how that looks. That looks sweet. Right, now we can measure out the space that this would take up from one extreme to the other. Well, we know it's a 250 millimeter radius, so I would imagine it's going to be a bit more than 500 millimeters, which is a hell of a lot better than 1 meter. 541 millimeters. That's almost half the size of what we had before, which I think is awesome. The height is going to be the same, but I think we could probably have these TP4056s horizontal. So if I go back to its sub-assembly, That's more like it. So I think if we do something like that, I think that would work a treat. Okay, so now we know what the concept the design is going to take. So I've already done the bulk of the work for this turret design on this BFC, but basically that was the main concept, was to try to take up as little valuable workspace I do have here and also make something cool. So taking our idea of the sub-assembly, I've taken an 18650 CAD model, battery holder, and fabricated this mounting bracket, which will be a laser cut, and most of the big components will be laser cut, mainly due to accuracy of the parts. It has a through hole for the terminal pinouts of the battery holder, as well as small pre-drilled holes to allow me to screw the battery holder to this acrylic mounting plate. Bringing that into the larger assembly, I can then create the 66 array turret with the TP4056 on top. This now leads me to pre-wire sub-assembly as well. So if I zoom into the individual wiring of the TP4056, you can see it goes through the bracket into the positive terminal as well as the negative side. So that means now the battery is connected to the TP4056 for charging. We now need to create the connections to power up the TP4056. And that is another array of wiring that will come out of the pin-ins for the TP4056 and lead towards a central bus that will provide the power supply to the TP4056. So there's two buses I've created here, which is out of 3-core wire. So already it's looking fairly complicated, but really the holder would be pre-wired with the wires coming out. The TP4056 will also be pre-wired. And then all you would need to do is you would just basically join and solder the wires through the hole on top of the turret. The actual bus are just a simple copper wire, which is sufficient to hold the current required to power the TP4056s. We obviously need to then think about cooling the TP4056 chipsets. I've given this some thought and decided the best way to do this that is readily available is to use an 8mm copper pipe, which can be available hopefully from most plumbing places. It's a simple copper pipe that will basically be thermally connected to the chipset. Seeing as it's a pipe as well, I thought it'd be a good idea to put some sort of cooling system in there. What's readily available is a cheap and cheerful pump. I think this would cost £10 sterling. I don't know what that is in your countries, but it's a very cheap pump basically. So the pump would be connected to this pipe via some silicon tubing, and it will circulate water. I don't think it needs to have a radiator of any kind because it's basically containing the displacement of heat throughout the copper piping so that the heat is evenly distributed between the TP4056s. Because we've got that as well, we might as well bring in a temperature sensor that will be connected to the pipe, maybe through the outlet pipe, so you can see what the temperature is whilst it's charging the units. The whole unit will be powered by a standard PSU, which is rated at 5 volts, 70 amps, a 350 watt power supply unit, and that would be wired into the bus directly. So already it's looking fairly complex, but it's really just small sub-assemblies that will be linked together to the bus. We need to enclose this whole unit, and if I bring the top disc into effect, you can see that it allows you to see the cooler tank temperature of the pipes via this digital readout. The TP4056s will sit on top of the top disc as well as the copper pipe. So the bottom side, it also needs to be enclosed. There we go. Now, these holes are basically just for the power supply unit. We've got the pump. I should have mentioned the pump sits away from the bottom disc. So there is a tank holder. That tank holder is just a 3D printed part which will hold everything together, and then that in turn it connects to the bottom disc like so. Now the whole unit is encased and enclosed, so there'll be no sort of risk of electrocution of any kind. The batteries are spaced evenly so that you can get your fingers in and out. Obviously, regarding putting these side by side, there is that big issue of trying to pull out the battery, so there's enough finger gap there for you to remove those batteries. Once I'd assembled this, I thought the best way to be able to navigate around this unit is to make the actual unit rotate around a axis. So I went about designing a spindle design, and really what I wanted to do was try to use off-the-shelf parts, and I decided to get a PVC pipe. You can also 3D print that part out, and that will actually provide most of the backbone and support for this BFC. That needed a way of being retained within the unit. What I've done is now the unit has to be connected to some sort of hub the turret is fixed to. And if I remove that, then you'll see a lower part which will then be just fixed together via, I can't remember if it was an M5 or M6 screw and a nut at the bottom. So yeah, so this would then sandwich the top disc, allow you to rotate the whole unit. The PVC pipe is obviously cut, and the wire is the mains cable. There's only one wire that comes externally to provide power to the power supply unit. Now that that's in place, we needed to think about the bottom side stand, and there I created some more 3D part components, which is basically a stand like so, and it has, I can actually open this up separately so we can have a look at it without all the other stuff behind it. Here we go. There you go. It's in two colors for your convenience. So this is one piece that can be printed out. It fits my Prusa only barely, so it should fit other 3D printers quite comfortably. It has a kind of a 608ZZ or ZZ bearing which rides on the bottom side of the disc. So you can see here the bottom disc rides around that, and it provides stability and support for the turret, for the BFC. And it has rubber feet at the bottom. It has an inlet wire that comes through here and out of the center, or come out of the PVC pipe. So it'll come out through there and out the top. Okay. And that's about it really. I mean, it's designed so that it's fairly easy to print. It's got some weight saving or space saving features on the spindle. It just holds an M8 bolt, M8 nut will hold that all together. So this thing rotates. The one other issue that we have regarding a turret is that we can't allow it to freely rotate, because obviously there's an external cable that comes in through the bottom, and it will just wrap around and cause issues. So we need to limit the rotation just about a 360 degree. Basically, one of the bearing holders or retainers has a step that looks like that, and this bracket is fixed to the bottom disc and prevents it from rotating any further than 360 degrees. And when it goes all the way around, it'll hit the other side of that, and that's what stops it from rotating. There is one more thing I forgot to mention. The buses themselves, they are floating in space originally, and that's a very simple 3D printed component that will comfortably sit within there and retain the buses. They just basically clip in, nothing complicated. They clip in like that, and that clips in like that, and that would retain the buses. Okay, so other than that, that is the design for the BFC. I want to know what you guys think. Should I make it? Should I not make it? Have I overlooked something in the design that is seemingly overlooked, but I haven't seen it? Maybe you guys can tell me. I don't want to change the design too much, so don't come back and say to me, or automate it and have a server come in and swap the batteries out. This is purely just to charge the batteries up so that they are in a state where they can be discharged, ready to check their capacity. Okay guys, I would like to see as many thumbs up and likes so that we can order all the parts in and assemble this, and let's get this machine working and see how well it works. I'd also like to know what you guys think about these design processes and the CAD sections of these videos, and does it interest you or doesn't it interest you? Should I reduce the amount of design information I give? That kind of feedback will help me make better content for future episodes. So what I'm going to do is I'll leave you with a slideshow of some screen grabs of the design, and obviously do get back to me and let me know what you think. Should I make this or shouldn't I make this? Hope to see you again. Take care.